Good evening. Evening, sir.
Hey, who are you?
Bad, sir.
Sir, I would have gone farther, but it's just that it's a little confusing. As I mentioned, the iterations, the steps before you make the next one is kind of confusing me. So I keep doing it over to just to kind of get a better understanding of what is what I'm doing. So it's about like 5 times now I do it over because I wasn't here from the start of it. It just confused me.
Totally understood. I soon come.
Greetings everybody. Out in the open here. Could anybody give me an update as to what exactly is should happen? Should be happening.
Sir, as in which class?
Right.
Calculus 2, sir, for MIS and IT.
Also, he is just paying attention to accounting for who exactly is in the groups. Is that the case?
Not sure, sir.
But it's sir though, cause I was pretty sure I saw the whiteboard a while ago.
Say again?
No, where's the whiteboard? Cause I'm pretty sure I was try, I was trying to look at this a while ago.
Oh, I see.
Again? Seriously?
Okay.
Further texting in the chat, he got disconnected, Mr. Shan.
All right, students, can you hear me now?
Yes.
Yes,
Loud
sir.
and clear, sir.
Oh, Jesus.
Yeah,
Thank
man.
you. Thank
Success.
you.
No,
Thank
no.
you. Thank
Progress.
you.
No.
Thank you.
Progress. No. Wrong word.
Thank you. All right, please. I crave your whiteboard. External meeting participants cannot access this whiteboard after the meeting because external cloud sharing is disabled. Okay. I crave your forgiveness and fulsome understanding. All right. So for the sake of those who were not following, I am going to start this from scratch. So I'm going to ask that you give me, please, the function that we worked with. We started off with f of x equals
X cube minus 4x square plus 1.
all right. Now, so we've been struggling to complete this question from last night. So I'm going to ask that you just, stick very close to your system and try and work with me as best as possible. We need to finish off this question so that I can give you some additional questions. Hopefully the system won't act upon me again. So we're given a question. We're not given the first iteration. In some questions, they will give you what x1 is. In this case, they didn't give us x1. So what we are going to be doing is to find a value. Now remember, how many roots this question has?
3.
Three roots. Three
No.
roots. Very good. It has 3 roots. Why? Because the order of the operation here is 3. So once we solve this, we should get x equals something, another something, and another something. Now, what we are trying to do, the question will ask you to find one of the roots. So when they don't give you the x1 value, one grouping of students may find one root, another student may find another root, and then a third student may find the third root. In a case such as this, when I am marking, even though 3 students got 3 different answers, those answers are correct. Now, if I gave you what x1 is supposed to be, it means that everybody is supposed to get the same root. Once I give you what the x1 value is, everybody should get the same answer. If on the other hand, I just leave it open like I'm doing now, it simply means that each student can get a different root. I decided to start with f of 0. So we have to start with f of 0 now. But I decided to start with f of 0 to investigate what is happening. So f of 0 is going to be equals to 0 cubed minus 4 times 0 squared plus 1, which is equals to 0 minus 0 plus 1, and this here is equals to 1. Remember, Nigel asked a question yesterday, sir, is it this one that is circled that we are now using to find this f of 1? And the answer is no. What I'm doing is using consecutive numbers. So I can't use f of 0 and then jump to, let me see what f of 2 is going to work out to be. No, I can't. So if I'm going to be using 0, my next number must be 1. If I'm using 1, my next number must be 2. I have to use consecutive numbers. I must use
Because
consecutive
it's
numbers.
a linear equation.
I use the consecutive numbers because if I jump from 0 to 2, chances are I may end up with a positive number. And okay, let me not say that. If I jump to 2 here, yeah, I may end up with a positive number. Okay, let us try something here. 2 cubes minus 4 times 2 square plus 1. 2 cubes are 8. 2 twos, 4. 4 4, 16 minus 16 plus 1. So that's 9. It's going to be equal to negative 5. So I may say to you that my value lies between 0 and 2. And when I take the average of that,
Oh,
I'm going to end up with 1. You follow
mhm.
what I'm saying?
So
But
that's really not close to the.
very good. It is not close to it because we already decide from yesterday that our answer lies between 0 and 1 and that our x1 value is 0.5. So you start off here. So it means that you may have to do the iteration many more times than you are expected to do. So in order for you to get this answer, you may have to do the iteration 6 times or 7 times, and that is wasting time. That's wasting time in an exam compared to a student who follows the rule and able to get the answer. And a question on this, guys, trust me, I'm trusting that there's no Hurricane Melissa come up. But a question like this on the traditional exam paper carries anywhere between 9 and 11 marks. All right, so it's a good enough mark question. Okay, so just remember consecutive values. Consecutive values. So let's go. So f of 1 is going to be equal to 1 cube minus 4 times 1 square plus 1. That's 1 minus 4 plus 1. That is going to be equals to -2. So hear me now. Since f of 0 is equals to 1 and f of 1 is equals to -2, comma, it suggests that one root of the equation lies between 0 and 1 since there was a change in and you're supposed to understand what I mean by range. The range is a f of x value. The range is a y value. All right? Now, so therefore, to determine x1, we're going to find the midpoint. That is 0 plus 1 over 2 is equals to half. So therefore, x1 is equals to 0.5. Do you agree that a half is the same thing as 0.5?
Yes, sir.
All right, good job. Now, recall x to the n plus 1 is going to be equal to x to the n minus f of x to the n over f dash, come on, x to the n. That's the formulation for the Newton-Raphson. That's the formulation for the Newton-Raphson. All right? Very important that you know that formulation. You are not going to get a formula sheet. No formula sheet is going to be given. All right? So let's go. So now that I have my x1 value, what is the next iteration I'm trying to find? I have my first iteration. Now I'm going to go to the
X2, sir.
x2, right? And x2 is going to be when n is equals to 2, right? So,
Mhm.
so now So the second iteration. So f of so I'm gonna recall f of x is equals to x cubed minus 4x squared. I'm saying this from memory. Plus 1?
Yes.
Okay. So now f of 0.5 is going to be equals to 0.5 cube minus 4 times 0.5 square plus 1. What is 0.5 cube equals to? 0.0625? Sorry,
0.125.
125, sir.
0.125. Right. 0.125. 0.125. I said 625, but it's supposed to be 125. 0.5 squares is 0.25 times 4. What is this equals to? 1?
Yes, sir.
So f of 0 is going to be equal to 0.125. Let me pause here and ask, is there any question? Okay. Now, I'm going to evaluate f dash of x. F dash of x is equal to 3x squared minus 8x. Agreed?
Yes.
Okay. So now,
Oh,
f
sorry, I
dash of,
differentiate.
yeah.
Okay, I was confused for a moment.
Okay, f dash of 0.5 is going to be equal to 3 times 0.5 squared minus 8 times 0.5.
I get negative 3.25. Negative 3.25.
Negative 3.25, everything? Final answer is negative
Mm.
3.25?
Yes.
Okay, good. All right, now. So
Sir?
look up. Go ahead, please, sir.
Yes. Whenever you're iterating,
Mm-hmm.
that is for each iteration, you're going to differentiate multiple times. Based on the squares, based on the cubes.
I'm not differentiating multiple times. It's just going to be one differentiation, but I'm going to be substituting each value into the differentiated function in order to get the new iteration, the iterated value. So
Right.
I'm not finding anything more than f dash of x. So I'm not, when it said differentiate multiple times, it means that I'll find f double dash and f triple dash. No, I'm just finding f dash of x, and then I'm going to be finding, I'm going to find that differential at different points. Follow me?
Okay.
Right.
All right. But before you go though, to whom am I speaking?
Yeah, this is Daniel Thomas.
Okay, Daniel, I'm going to ask you to change your name for me, please. I think
Oh,
this may be the
okay.
first time I'm talking to you.
No, man, it's been a while actually.
It's been a while. Okay, yeah. So
Yeah.
let's change that from whatever that is, please. All right.
No
So
problem.
are we understanding so far? Anybody wants me to go?
Yes, sir.
Okay, good. Anybody wants me to go through anything? Because it's from yesterday where I tried to this question, and it now gonna get the better of us. All right. So let's go. Let's continue.
All right, sir.
And if you
One
have,
moment.
go ahead.
If I'm following. All right, so quickly. So when we start out with the function, we are finding the values. Well, we're finding sequential values for f0 and f1 to then determine a midpoint. And then after we determine that midpoint,
Sorry,
we-
no. When you say F1, is it F of 1 or F dash you're talking about?
F of 1
F of
in
1,
the
okay.
starting of
Okay, you're correct.
the solving process.
Yeah, man, you're correct. I just wanted to make sure. Correct. Continue.
Yes. So F of 0 and F of 1, we then determine a midpoint.
Uh-huh.
All right, and then after that midpoint, now,
Sherry, let me just stop you, please. I'm going to use your question as a teacher at the moment. So if when I calculated f of 0 and I got a positive number, and if I calculated f of 1 and got a positive number, could I use that, Chevy?
oh, I'm taking that there's no difference in range. It's like a continuum.
Right. So I would not have crossed the x-axis to get a different right. So therefore, I'd have to go now to f of
2.
Very good. And if I got a positive number again, I'll go to
F of 3. Okay,
good.
so it's
And if I
until
got a
you get
negative
the
number
change in
if I got a negative number for f of 3, my answer will lie between what and what?
lie between 0 and 3.
No. Lie between what and what?
Oh, 2 and 3.
Good job. Continue with the question now.
Okay, so it's whenever you get the change in the range, use those
Right.
two values. I'm
Right.
taking
Right.
part cool. Then after we find that midpoint, we then use Newton-Raphson formula to say x n plus 1 equal x n minus f of x n over f dash of x. And so I'm taking that we have, let me see here. So from the midpoint, we're going to substitute the x value with the value of the midpoint to then determine the second iteration and then to get the derivative, if I'm making sense.
I don't know if that helps.
So x2 is equal to x1 minus
F of
the
x1
value. Mm-hmm.
over f dash of x1.
So,
Okay.
So go ahead, please.
for,
Somebody's coming in?
no, it's just me. So I'm just looking at what you wrote. And based on what you said for x2, it would be x1, which would be 0.5.
Good job.
Based on what you determined.
Mm-hmm.
And we subtracting from the function over its first derivative.
Yeah,
Is
but
that
tell me
right?
now. Yeah, man, but tell me now, Crosswell. What do I write next? Minus what?
It would
Did
be,
we evaluate f of x1 yet?
Yes, sir.
yes.
It's 0
Yes, we
0.125.
did 0.125.
Did we evaluate f dash of x1?
That's negative 3.25.
Good job. So that's what we now need to evaluate. So
Oh, so, sir, the n represents the number of iteration.
yes, ma'am.
Okay.
Right. So all right. So when you're doing this type of function, but now I'm just curious why I haven't bracketed the division.
By having what?
This might sound like irrelevant, but I was just curious why you never bracket the division part of
I don't have to.
x2.
I don't have to. I don't have to. But when I divide two negative numbers, though, Crosswell, what do I get?
It's supposed to be a positive.
I get a positive.
No, wait,
Okay.
that's
What is 0.125 divided by 3.25 equals to?
I'll do that.
I didn't do something for the question. So forgive me. And I'm going to tell you.
0.0 negative 0.0384
I didn't do something for the question. So I'm going to ask that you forgive me. to 3 decimal places.
Yeah, I was gonna ask about that. How far the decimal places should be.
Yeah. And
I
I'm going to tell
use
you, I'm going to tell you why it is, I'm going to tell you why it is important. The decimal places are very important in this case because if I don't do my rounding off, I am not going to be able to get my desired result. And I will come back to this one when I reach the final question, the final thing. Well, let me say it now because it's important. I'm coming to you. I hear a question, but I'm coming to you. Let me tell you why it's important from the start that you know how many decimal places to work with, because there are students who may want to work with a rounded value. Students may want to work with 1 decimal place. In order for you to get your desired results, you need to know how many decimal places you're working with, because in this case, working to write your answer in to 3 decimal places, I am going to be working in 4. So if the question says determine the root up to 3 decimal places, work in 4. If they say determine the root to 2 decimal places, work in 3. If they say determine the root to 1 decimal place, work in 2. So any amount of decimal places they're asking you about, work it in 1 more than that. Work it 1 more than that. Make sense?
Right. Yes, sir. I
I'm
use
still
4.
right. Great.
So,
Student, go ahead. Go ahead.
mhm. Yes, yeah, that cleared up my question. But I had another question from before, just for clarity, sir.
Mm-hmm.
Where you have, because you mentioned that depending on the value that we get, if it's a negative or a positive value, that will determine where we choose, where we decide that the midpoint is going to be. So
Mm-hmm.
you say in this case we got 1 and -2. So that means then the midpoint will lie somewhere between 1 and -2, and this is why we choose.
No,
No, no,
no.
no, no.
The
Hold
midpoint will lie
on, no,
between.
sir. No, I get it. Yes, it's not. I did not say that correctly. So it's because you use the two things, 0 and 1, F0, F1, F of 1 and F of 0. That's oh,
So that my answer
sir,
now
I
lies
can't
between
go
0
now.
and 1. No, you're correct. You're doing very well.
Yes,
So my
yes,
answer now
right.
lies between 0 and 1, not the 1 and 2,
Thank
but the
you.
0 and 1. The 1 and 2
Right.
is just indicating that, remember the 1 and 2 is indicating now that you have reached your exact point or you've crossed over a threshold. Yeah. So the answer there is going to be is going to lie between whatever X value that we are substituting in.
Hmm.
Right. So that's why it's going to be
But
0 and 1.
you mentioned something about if it was a positive, two positive numbers that we had gotten, sir. So
Mm-hmm.
that's what I'm saying now. So for if F0 is 1 still and F1 is positive 2,
Mm-hmm.
what then we wouldn't be using 0. What we have 0.5, the halfway point between 1. Sure, man, I get what you say
Okay.
about the
So
positive.
Chevy, I just explained this to you. Can you take the class 3 for me, please? Let me see if you fully understood what I said, Chevy.
I take it that with back from the top where we were discussing f of 0 and f of 1, right?
Correct.
So whenever, for example, if f of 0 gives me a positive number and f of 1 gives me a positive number, there's no change in the range. I look at it as a continuum of whether on the x-axis, I believe. So there's no change over to or crossing over from the negative side of the x-axis, I take it. So if f of 1 gives me a positive and then f of 2 gives me a negative, I will use the f of 1 and f of 2 values, not starting from f of 0. So I think you always move one further or down the line further when you use the two values of f of 1 or f of 0 or f of 2 and f of 3. Wherever you get a negative value is between those two numbers that you'll be using or you're starting from, if that makes sense, sir. if we got.
Got that, Moya?
Yeah, I guess so. So
Right.
wherever you get the negative value, that's the point as well, and the one before that you're going to use to find the midpoint.
All right. So I don't like how you say it whenever you get a negative point. It has to be a change of value. So you could have gotten the negative value first, and then you get a positive value after. So it don't have to be plus
Sure.
first and then minus after.
Oh,
It
one
could be
last
minus
Yeah.
first and
time.
then plus after. You just have to have
One
a change
last
of value.
time. One last. This is my last shot at this.
Sir.
So the
No, hold on,
change
hold
of
on.
value.
Go ahead.
What what Chevy was saying is the 0 and the 1, so that's F0, F1. That's a continuous. That's the continuum that you're talking about. And because you got the negative, the positive 1 and negative 2, you see the change in that direction. So that's
Very
why
good.
we okay. All right,
That's how we
so
use the
I
zero and
get
the one.
Mhm.
Yeah,
All right, sir.
but I want to go a little further though, because I want to make sure that you fully get it. So what I
All
was
right.
Chevy asked a question, and the rest of you, I want you to listen. This is not a conversation just between Maya, Chevy, and Sir. I want the rest of you to listen to this conversation as well, because it may very well come up and you have to do it. So the conversation is, okay, sir. So yes, I understand that when you make a substitution of f of 0 and you get a positive value in this case, and then you make a substitution of f1 and you get a negative value, you see the change in the value of the range. So therefore, you know that your results, your root or one of the roots lie between 0 and 1.
Right.
What I'm saying to you is, if when I calculated f of 0 and f of 0 is positive, and I go ahead and calculate f of 1, but f of 1 is also positive, it means that I have not yet found one of my roots. I have to now move to f of 2. If when I calculate f of 2 and I still get a positive number, I still have to go on one more time. But when
Right.
I calculate
Oh,
f of 3 now, and f of 3 give me a negative value, I'm going to say, haha. Therefore, my answer is going
okay.
to lie between which one and which one.
Um, F of 2 and 3.
So that my answer is not f of 2, but my answer is going to lie between 2 and 3. So one of the
Right.
roots will lie between 2 and 3. So it's not just
Oh,
you substituting those and then finding the midpoint. So you are now going to be finding the midpoint of 2 and 3. So it's going to be 2
right.
plus 3 is 5. 5 divided by 2, you're going to have 5 halves. So that is going to be your
Oh,
x1 value.
oh, sir. So it's kind of like, as you mentioned the other day about being at a specific location, and the
Absolutely.
person could either go down the road or up the road. So you
Absolutely.
need to find a midpoint
Correct.
between. So the
Correct.
positive would be the right, and the negative would be the left side.
Correct.
So,
Correct.
and then you have the midpoint. All right,
Correct.
sir.
Right. And as you make mention of that real life situation I gave you on Tuesday night. So you remember the question that I just did a while ago when we said, what did we say? When we said so if you remember Chevy was saying that, oh sir, so we're gonna use 0 and 2. And I said, no, we're not using 0 and 2, because if we use 0 and 2, it means that our midpoint is going to be 1.
Mm-hmm.
1 is going to be way too far from the
Too far
situation. Yeah,
from the
man.
right.
Because guess what now? Let us go back to the real life situation. Somebody got abducted in half a tree. And then you are going to now say to the police, you will call downtown police, CIB. It don't make sense to call CIB. It don't make sense to call CIB, because by the time
By the time
CIB
we get there.
hustle through the traffic, this somebody gone up
Right.
Port Royal, right? You see what I'm saying? So what you're trying to do now
Right.
is, and this is why these police stations are interconnected, and you have radar control to say, yeah, okay, let me not even use that. Let me use Uber for argument's sake. So you call Uber and you say, yo, um, I am at Mountain View Avenue, and I need or Seven Crave, and I need a 20-piece chicken nuggets from Wendy's. Somebody who is working with Seven Crave in Portmore wouldn't necessarily take up that order. Make somebody in Kingston who say, yo, I
Right.
will take this order because I'm here. It's same thing happens with the taxi service. It's same thing happens with the Uber Eats. It's the same thing with Lyft. So, I mean, this is so applicable to real life situation. Ambulance services. So if there's somebody who needs an ambulance service, accident happen, man get licked down, you're not gonna call an ambulance from St. Catherine. You're gonna call the radar system and ambulance who is closer to that section will say, okay, fine, we will respond. Fire brigade. Is so many examples I'm giving you with this because this is real life. By the way, where's Dijani? I've not seen her from Tuesday. She's not doing this course. Sorry.
Not sure.
Say this again.
Not sure if you hear me, but you have the option. So I believe when Mr. Parchment was giving me an option, you can
Mhm.
either do all fourth year courses for this semester, or you can either do continue with calculus and do a portion of the fourth year courses. So I'm not sure if she's doing the all fourth year, then doing calculus next year, or she's like me doing calculus now, then finishing up fourth year next year.
Oh, I'm kind of dangerous, you know. And I'm going to tell you why it's
Yeah.
dangerous because um in the original structure, calculus 1 and 2 are both offered in year 3, first and second semester respectively. So you picking up calculus 2 in the second semester, there is no the timetabling is going to present clashes and
Yeah,
and
it does. It does.
yeah, man, and trust me, I've had students who failed calculus 2 with me in their year 3 and carried it over to year 4. And the only reason I give them time off, meaning instead of coming, so for example, they would have had, say, programming timetable at the same time with calculus 2, but they are doing programming for the first time, but they've already gone through calculus 2. I would say to them, come and spend the first hour with me and then spend the last hour in the other class. And it, he's the head of department. He should know why he's saying that. But as a math
For,
lecturer, I'm saying to you, it's difficult, risky.
yeah, fortunately, sir, for this year, I believe, with mine, um, this I think is on Thursday. The clash is between this and telecommunications. But
Mhm.
fortunately, it's a lab session and it's a 3 hour class. So I can always make up at the time in the lab session. So it's not
Got you.
too much. So it's
Got you.
fine.
Got you. All right. Thanks for that. Yeah. Yeah.
Sir, I had a question.
Go right
I
ahead, please.
wanted to ask in relation to understanding the
Change it.
iterations, or so to
Change.
speak, the
Change your name
functions
yet,
exactly.
Hold up. Change your name yet, Papa.
Yeah?
Change your name yet,
No, I didn't hear you.
You didn't change your name yet on the
Oh,
Zoom
I
thing.
see. I see. Oh, but just pardon me with this question or the
Uh-huh.
comment that I have in
Uh-huh.
relation to understanding this. Okay, so with x2 equal x1 minus f of x1 divided by v, so to speak, divided by the differentiating aspect of it, right? What is taking place here? Because I know that this is not necessarily an iteration. Is it to get the range or the root of something? Is to get the root of y?
Yeah, that's the end result. So I'm doing several
Mhm.
iterations so that I can find one of the roots. Remember, it's a cubic function. The order of
Mhm.
the operation there is 3. It means that I have 3 solutions. So I'm trying to find one of the solutions. So I'm going to do
Mhm.
the iteration as many times as is necessary so that I can find the root of the function, one of the roots of the function.
And that is the y, the exact point on y, right?
All right, I'm going to answer you yes for no, right?
Mhm.
So my first iteration was 0.5. I am now performing the second iteration. If I get 0.5 for the second iteration, it means that my root is 0.5. Because once I have 2 consecutive values for my iteration, it means that I have reached my endpoint. It means that I've reached my endpoint. And even if I did a third iteration, I will still get 0.5. And if I did a fourth iteration, I will still get 0.5. But if when I do this, when I finally calculate this x2 value, and if I get a value that is outside of 0.5, it means that I have to perform the iteration a third time.
Okay, so this iteration the point of, cessation would be exactly what? What is the indicative? What is the indicator of that based on the answer? What
When I get
answer
when I
tells
get
that the iteration should end?
I just told you, when I get an identical value. So if my first iteration is exactly as the second iteration, I would have come to my endpoint. If successive iterations are not the same, I'll have to continue the iteration until I find successive iterations that are equal.
Mm-hmm.
You
Oh,
follow
that
me?
are equal. So what would you measure it against? What would be the comparative equation, so to speak?
Let me tell you a while ago.
The
I use
last
one word that starts with E. Tell me what it is.
Well,
No, use the word now. What word I say a while ago? It starts with E.
equal.
Equal, right. So
Mm-hmm.
once it's equal, boom, it done. And you will see
Equal
the
to what
equal.
exactly? That's
All
what I'm
right.
trying to
the
figure
All
out.
right.
last
Press pause. Press
Mm-hmm.
pause. We'll soon get there.
All right.
We'll soon get there. Thanks for the question though, but we'll soon get there. Do me a favor. I need for somebody to evaluate what is 0.125 over 3.25 for me. To 4 decimal places.
0.0384, sir.
0. Sorry. 0.384. No man. Next, let me take
0.0384, sir.
0.3
Remember
0.0.
that for round up, if you're gonna put it to 4.
Oh no, that might have, sir. The 4 decimal place might have. That's
Sir,
right.
I have 0.0385.
Yeah, can you round up, round up?
Round it up, yeah.
I understand. Wait, no. I foolish. 0.5385. That's what I. Wait, no. What am I
No,
saying?
Maya, no, Maya.
Sir, you
The
said
other
what?
answer was the correct one.
Yeah, right.
0.125 divided by 3.25. Answer equal
Yes,
Mm.
0.0385.
No, man, I
0.
negative that.
Yeah,
Negative,
no,
negative.
no, man. Hold on. Let me get a value for it.
Because
0.
the negative cancel each other, so it's a positive anyway.
Oh, my bad.
Yes, Jay, that's correct. All right,
All
so let
right.
me go. So 0.0385.
Yes, sir.
Yes.
0.0385. 0.0.
You're not
Oh,
buying a
yeah,
new
did
pen
find
or
your calculator, sir.
0385. No, I'm just trying to figure out 0.0385 is written. So that's why I keep saying it in my head. So
I'm thinking about
0.0385.
a new pen.
Yeah,
I
but
think
my
the pen
round
I
up
get
the
you.
last, that's what? The 5th
Yeah,
digit, sir. But
But it's a
me
4,
never
but
run it off.
sir, say
but
four decimal places. So that's
thank
a
you.
four.
Yes, so
Let's say four
if I say
decimal
four
places.
decimal places, you have to look at the fifth decimal place. And if the fifth decimal
Mm,
place is greater than five
Yeah.
or greater, you add one to the one
yeah.
before.
All right.
Yeah,
Right.
and then add 0.0385 now to 0.5 and tell me what you get.
0.5385.
All right. Okay, you see, because you don't change your name, yet I don't know who you are. Who okay. Chevy, can you pass over the host to me, please? So I can change his name. Thanks.
I'm changing it, sir. Are you aware of my name? I'm Daniel Thomas, actually.
I don't know his name, no, sir. So I want you to change it now, please. So I can.
Yeah, man, will do.
All right. Okay. So Daniel, if you look now at my first iteration, what's my first iteration? 0.5. What's my second iteration? 0.5385. But sir, you said that you wanted the answer to 3 decimal places. No problem. My first iteration, therefore, is going to be 0.500. But this one here is going to be 0.5385, right? So do I stop or do I continue?
You continue.
I continue because the iterations are not identical. So I am going to press pause, and you are going to do this for me. This is what is going to be done. So for my third iteration, for my third iteration, okay.
So I ended up doing it up to 4.
And did you get anything to be equal?
Yeah.
Okay,
I
good job.
got. Mhm.
Good job. I'm happy for that.
Well, it wasn't necessary for me to go up to 4 because when it went up to 4, I got 0.54. But still, when you round it off the others, you would have still get 0.54, you know.
Got
That's
you.
if you round it up to 2 decimal places.
Sure, can you repeat what you just said in terms of the third iteration?
All right. So what I want you to do the third iteration for me. So in order to find the third iteration, you are going to use which iteration now?
The second.
The second one. So in order to find the
So
third
it's going
iteration, you're
to
going to use the
be
second one. So x3 is equal to what?
x2
Uh-huh.
minus f of x2 over f prime of x2.
Good job. Good job. All right, I'm going to press pause right here now. Was it you, Chevy, or was it Daniel? I think it was Daniel. Daniel, you were asking, no, Chevy, one of the two was asking if I'm going to find multiple differentials. And I said, no, you're just finding one differential. Just one differential you're finding, f dash of x. You're not interested in the second derivative, neither you're interested in the third or the fourth derivative. So you're finding just one differential. So each time you're calculating at that point using your new iterated value. So what I want you to do for me now, I am not doing it. I want all of you to go ahead and do it. Go ahead and find x3 for me. x3 is going to be equals to x2 minus f of x2 over f dash of x2. So what you're going to be doing, remember, the final answer is supposed to be to 3 decimal places. So you're going to work your calculations in 4 decimal places. So what you're going to be doing is 0.5385 will be substituted into the function f of x, and 0.5385 will be substituted into the first differential, f dash of x. Go ahead and do that for me, please.
Sir.
Yes, please.
One other thing I meant to ask in relation to what you call it, the f of x and the first f of x, so to speak, or the derivative,
The first derivative.
The first derivative, right?
Mm-hmm.
So, you would, yes, you would replace them, so to speak, with the
x2 value.
value, with the x value, right, of x roots 2. That's what you see over here. So it would be replaced. It would be replacing the value that you get. It would be replacing here. That's the case?
Were you here on Tuesday, Daniel?
No, I wasn't.
Okay, all right. All right, so I'm gonna answer you, but I'm gonna use your question as a teachable moment. Were you here yesterday?
No, I wasn't here yesterday.
No, Daniel, you can't come class once a week, about 3 times a week we meet here. All right. All right. So I'm gonna answer your question, but I'm using this as a teachable moment. All right, students, remember on Tuesday and last night as well, I referenced the start of the class with a drawing, a section of a curve cutting the x-axis where my exact value is.
I
Yes, no, maybe so.
vaguely recall.
Yes, sir. Yes, sir.
When I did my initial guess and I got my x1 value, and then I drew the tangent.
Oh, yeah.
Good. When I drew that first tangent, it is when I did my differential to find the slope, the change in y over the change in x. And then now, when I got my new iteration, which is my x2 value, I have to repeat the process because I have to now draw a tangent and extrapolate it to see where it's going to cut on the other graph. So which is why every time it is moving, think of it this way. I don't know how many of you would have experienced this, but when I buy things on Amazon, for argument's sake, and it says that it's going to be delivered tonight, and I go on and check, sometimes I'm seeing a map and it tells me 5 stops away, and I literally can see when the Amazon vehicle is in motion and it's moving, and then it says 3 stops away and 2 stops away. That's what the iteration is doing. So it is inching closer and closer and closer and closer until it gets to that root that you know, say, yo, this is my final answer. So coming back to you now, Daniel, is for each iteration, you're going to test each value. You're going to test each value. You're going to test each value in our formula. So you get the x1 value, you're going to test it in the x2 is equal to x1 plus, minus f of x1 over f dash of x1. That's the formulation. Then when you catch your x2 value, you're going to test it now because that's the iteration that you're doing. So when you get your x2, your new x2 value, you're going to say, okay, x3 is now going to be equals to x2 minus f of x2 over f dash of x2. When you get your x3 value, you're going to say, okay, x4 is equals to x3 minus f of x3 over f dash of x3. So each iteration that you get, you are going to be testing it to see what happens. I guarantee you, as Moya says, sir, when I did the fourth iteration, I got it as the same as the third iteration. But we are going to check Moya's theory to see if what Moya says that she's calculated or she has calculated is actually correct. But you, coming back to you, Dan, I don't reach you yet again, But we will know where we are going to end because there has to be an end point. There has to be an end point. So we're going to know where we're going to end.
All right, sir, I need to clarify this point here. Yeah, so based on the fact that you have the iterations with Fn, you would not include the f of x and its derivative in the equations when evaluating these functions, given the fact, but I consider that because of the fact of here, where you have this, you would need it and the value that is there. So is that something that is required that you would use these, calculate it with these values?
Okay. Truth be told, I'm not following what you're asking. And I don't want to answer you and then I mislead you. So I'm going to ask you to go one more time. Say it one more time, Papa.
All right. So yeah, I was looking at the fact that given what you will have here at the, what you call it? The xn, yes. Given what you have here at the xn, and you would include it in the equation, the derivative, the f of x and its derivative, should you then include this value into the function and get the generated values as a result?
Yes, man. Yeah, that's what we're doing. So
Okay.
every time we are substituting or iterated value in this function to generate a new iteration.
Mm-hmm.
Yeah. So if that's what you're saying, the answer is yes.
All right.
So you see, just like how we did the x1 and we got 0.5, and then now we do the second one, we get 0.5385. That's a newly generated iteration. That is our x3. That was our x2, I'm sorry. We need to find the x3 now. I don't really like the x3 now. Really the x4 is my car. Coming like the x5 or the x6. X4 me like. Sorry, I just digressed a while ago. If you know,
Yeah.
if you know, you know. If you know, you know. All right. So we can continue. Have you done the x3 for me?
Yes, sir.
All right.
Wait a minute. There. Remember, sir,
Sir,
when may I talk out loud? Oh my gosh.
sir,
Yes, Nigel. Go ahead, Papa.
sir, my answer now I come back to your answer, no, sir, because my
Oh, but
calculation from start, but it start use the four decimal place, and I never round up like a Maya did that. So I got off by a few decimals. It gonna make a big difference?
it may no, but hold on, baby. Somebody decides to maybe them don't get my new timetable yet. To know say, oh, but it's not. Them not get my new timetable yet if they don't call me at this time. Sorry, Nigel. So you didn't use 4 decimal places? That's what you're saying?
No, sir, I never had that, man. So, the initial calculations, but it kind of have a different. So, where you have 0.385, may have 0.384. So, may I
Oh,
say the
okay.
final answer are gonna be a little bit off.
Off. Okay. All right. Okay. So you understand now why you have to make sure that you round off properly.
So, you're saying, sir, if a 3 decimal place and the 4 decimal place is more than 5, but just round off that and
You add one to the number before.
yeah.
You man. Same so.
Okay. Get you.
All right.
So I get the answer still. So I post some answer in the chat, so I get 5378 though.
Okay.
Maya have 5374. That's why I'm trying to understand if the difference are going to be detrimental.
Actually, no, I don't think so. And I remember it's like an approximation. So from what I am looking at is really the 0.53 because so far all of my answers are consistent with that. Up to the fourth iteration, I got 0.5418. But if you round it off to two decimal places, you're still going to get all of those. If you round them off to two decimal places, you're gonna get 0.54. So where sir say we should have stopped at the third iteration, looking at it now,
Oh,
it's going
stop at
to
it.
be. Wait, no, hold on, let me finish. So looking at it now, sir, it's like me as the police now, I reach the location, but I go a little bit beyond where I'm supposed to stop for pick up the person that got kidnapped, So that's 4 for me.
Got you.
So give or take a meter.
Yeah.
R2. Yes, yes. All right. Okay, fair enough. Are there any other questions so far on
No questions, sir. I'm tired. I want to go to my bed now.
Hello, you look. Oh, Roxanne, time run.
Sir, just
Yeah, time really flags when you're having fun. But guess what happened now? I don't know. It is the I am trying to write. Sir, me not get nothing away. No get. Hey, Chevy. I try Friday and you want to go the road. That's why you're not appearing. Matter of fact, you sound like you're there road, Chevy. And you sit down and run on one big table and eat. I eat your swims, buttered swims in.
No, sir. Wrong smaddy.
see
All
what
right, guess what?
sir want?
Straight up, fire pan swims. Jesus, no swim around. All right, I hear you. Jesus. Oh no, it's something else.
Sir,
All
you're
right.
rich, we know this.
And I'm gonna receive that, in Jesus' name. I'm receiving that. All right. I am.
Better get rich by mountain, Kaya, for a street all away.
You know what? I'm not even going to make you draw me out in a Maya book. All right, so I'm having a challenge now. My challenge is my pen has disconnected and I am trying to connect the pen. I cannot write. I can move everything else, but it is not. The screen is moving, but it is not. You see, Alex,
Why
Alex,
can I
Alex,
stick to
Alex,
one brand,
Alex,
sir? If a
Alex.
Samsung, I just Samsung, sir.
you know, you know, I dying for calculus to finish and on a pass on the course and on a graduate. No man,
Hey,
on a robot, you the teacher too much, No, Judge, no. Hey Chevy, the pen just disconnect and I can't even write with my big finger because it just disconnect totally. Moya, do me a favor. See if you can save this for me, Moya, and then let me come out and go back in and see if it can come back, please. Jesus, Father. Ay, ay, ay. Alex, me can't believe say you do that to teacher. No, man.
Sir, I'm
Chevy,
buying a new pen,
no,
sir.
Chevy, me couldn't understand. But you, Alex? No, no, no. Me lose for you, Alex. Big time.
Sir, I know you have the same pen, I don't understand. But
and that me I say it's same
So you
now,
might get a new
sir.
one by now.
By now, him not
Jesus.
serious about him job, Him not serious.
Oh God, Maya.
May I confess something?
You couldn't ask a pen for your pixie gift, sir.
Confess, it shall
Oh,
set you free,
I'm
sir.
I'm gonna I'm gonna confess. I'm gonna confess. Um, but kind of shame because Chevy. Somebody mute Chevy for me, please.
no.
So I actually bought a new pen, but
Hmm.
I try anyone, I pen come here, sir.
Why, Mr. Chin shop him
Oh,
go?
yeah, by the way, from Temu.
Him get chopped.
oh goodness, it's all right, man. I now pay on no man, You see, the iPad works and works beautifully, but me just kind of me not gonna lie to you. Honestly, after me done by the iPad, I cannot afford to buy a pen for $129. I really can't.
Sir, so me
Me
send you
not got
some
me,
money there.
well, if you don't want to buy one, I would say yes. But no, so I went and I bought another generic pen, a different generic one than the one I had before. But it not going too good neither. Me can't. Maya, save it, mommy.
Yeah, it's save.
All right. Chop.
Well, chop up five.
It's all right, man. Me not pay uno no money, no. Cause
Oh, yeah.
$129. And do I have $129? No.
Sir,
All right.
but the way you both see, you're supposed to can afford it. I
Um,
don't
after
know what
after
you're talking
after
about.
spe- after spending after spending $1,200 plus tax to buy the iPad, I can tell you straight up, I have no more money to buy anything more after this. Real talk. It's I just bought the iPad, $1,200 plus tax, us
Oh,
dollars.
God.
Right? So,
So you know, sir, I could have buy one good Samsung tablet and have change.
Exactly. Thank you. That's what I was about to say.
and you
Even
know,
better for this purpose.
me I go agree with you because when I recognize it, Apple now, Apple is like buying an apartment and you have to pay maintenance. Because everything
I
they
have
might
to
charge you
pay
for.
HOA, sir.
You have to pay
Mhm.
HOA. And I said to myself, then this me get tricked into to go buy expensive iPad and then now me have HOA for pay every month.
You buy expensive car and can't buy gas.
Talk truth.
Mhm.
All right.
A good name, yeah, rundown.
It's not
Good
good name me
name.
run down so me have iPad. I only make me do it you know because I bought new computer and it crashed. And I have tablet and it crashed. And I say, you know what? Let me just go to something that is decent. So Uno. Not the
Oh yeah,
government
you
money.
see him a play the playing game.
Uh,
Yeah, that's
Mm.
all I'm good for.
all right. All right. I need to. All right. So I just ended that. Um, let me go and see if I can
Anyway,
bring
we
Oh,
up
can
this.
get a
sorry, it
one question,
automatically saves
sir.
now. I think they set it up that it saves the whiteboard whenever you stop sharing.
Okay, yeah, man.
Because it's
It
in
is
the chat.
right.
Mm-hmm.
It is back up now. So
Okay.
all of that, you see you, all of that for costing me about
Yes,
my
sir.
generic pen. Is that right? You know, so not to you know. You just make sure so you pass my course, you know, and graduation, you know. That's
So
all me
the
want.
one in question if the
No man,
region of
you'll definitely get it, man, and you'll definitely get. I just want to make sure I finish this one good and proper. So we have 10 minutes. Let us see if we can finish off this one now. So the pen is back up. Thanks, Moyo. So Daniel, are you following? Second iteration, third iteration.
Repeat, sir.
Following?
Yes, doing so.
All right. So x3 is going to be equals to 0.5385 minus cockroach. Sorry, my bad. So I'm going to say f of 0.5385 is going to be equals to 0.5385. If you're not having a Kenko calculator, it's not going to work. You hear?
Anyone?
Minus Kenko, the Chinaman calculator, and the back, good calculator. 5385
Oh, God.
plus 1.
Sir,
Yes, please.
you need to chill. You need to chill. Oh, my God.
Hey, you remember the student who they have what the calculator the name shop again? Um,
Sir, behave.
no, I want to tell you, say she dey pass her business calculus. She cuss me out, though, you know. But she dey pass her business
Oh,
calculus,
my
man.
God.
And she said,
Deserved, sir, deserved.
she called me and said, Jesus, please, sir, I would have buy you anything you want right about now, sir. Sir, me pass? I
Mhm.
said, yes, man, you pass. All right, let's go. When you evaluated f of 0.5385, what you got?
I got. Hold on, the way say would they know?
F of 0.5385.
I get
Mm,
0.1561 minus 1.15.
can't even follow my own writing. Jesus, please.
Everybody agrees with?
Four,
No,
four.
I'm not reading
Sir,
calculation. No.
I got 0.1571. Not
I tell about that round off something there, sir.
Angel,
so.
you need to get some milk. 0.56. What are you? 5 what? 5.6?
571.
All right, hold on. I'm being confused. So look at what I have on screen.
Sir, the actual value that I got was 0.157110 something another. So because it's one, it not
Right, but
go
but
round
was
up.
that f of 0.58 5385?
Yeah.
Okay, all
Yeah.
right. So tell me the answers. Tell me the answer. Let me write it now. 0.5.
Sir, I got
Hold on.
0.156.
Okay, sorry. All right. We're talking about two
Actually.
different things.
So I can just
Sir,
do
the
it over.
0.5385 to the third power.
Yes,
I got
sir. It equals
0.1562.
0.1561.
62, round it off to 2.
Jaja, again the round off, sir.
Yeah, because it's a 5. 615, so you round it off.
Yeah.
Okay, so
Yeah, it's still the same, sir,
zero.
because depending on where they round off from, it will yield
All
a
right. So
different.
tell me what to do now. So 0.1
562.
571.
That's one of the values.
That can't be 71 because it's
No, it's
0.15615, which you round off the 5 to 1, which returns to 2.
No,
It will be 0.1562.
Aye, sir,
that
the
is
round
what
off
I'm
thing there for
saying.
Maya.
I agree with that.
It'll give you a
Because it's
fight
4
in there, sir.
decimal place.
It's
You
based
know?
on the fact that it's just because of continuous or proceed. I rounded off the values from up at the top there, sir. So that's why I get that, because I do them section by section, and then I finish off right there.
You know,
So
to be honest with you, all
Mhm.
along for all of calculus 1, I was able to trust you with the calculator. Calculus 2, I mean, yeah, I can't trust you all with the calculator. 5385. I don't trust you. I don't
Oh
trust
my
you.
Oh my God.
I don't
Sir,
trust
this
you all with the
is the best.
calculator. 5385 cube equal
It's literally
Sir, question.
0.1562.
62. The answer is 62.
I have a
6.
question.
Go right ahead.
Oh
Yeah,
Maya
so
gets
how
7,
it is
sir.
written in
Guys,
XN?
Hold on. Go ahead, Dan.
How it is written in XN, you would have it similar when you're matching it with the f of x in writing.
Yeah, man.
That's it.
I'm evaluating my f of xn and my
Mhm.
f dash of xn, and then just go ahead and do the substitution.
All right.
Sir,
Yeah. Yes, please.
Sir, hold on. Right there, you're doing the third iteration, right? Correct?
Mm-hmm.
Yes. So, that's what I am saying. For mine, or the same thing I have this too. So it's just the way I do it. I don't do them all. I don't put everything in one. I just do the division part separately, round off that value, and then I subtract it from the 0.385. So that's why I'm getting 7.51571. So that's what I'm saying. It depends on how you are doing your calculation, but it's still close values. It's an approximation, not an exact value, depending on how you round off and whatnot.
Sir, for
Sir,
the
Maya,
answer,
one of them
you
calculator
get
there, sir.
negative 0.0038.
37.
Mm-hmm.
All right. So listen to me now. As I listen to the confusion about this round off and that round off, that is when you separate the student who gets full mark from the student who gets lose a mark or 2 or 3 or 4 with this question. You all need to get good calculators. You need to know how to round off, because I'm saying to you, Once I have the value and I am doing my stuff, I'm expecting for each line that you write, and I'm expecting for you to have. But if I'm expecting 4 decimal places and give me 3, you start losing marks right there. So you and if miraculously your final answer has the correct answer, you still won't get full marks because each step matters. Sir, but if the final answer right, the question's supposed to be right. No, because the marks are attributed at different points. So if you miss those at those points, you will miss the mark. So I am listening to the conversation and I'm saying you have to do better than that. Go ahead.
Sir, so question. So for right there, I got 0.0038. And again, I'm saying I evaluate each of them. So that 0.0
I won't penalize that.
0.38.
I won't penalize that.
Right. So that's what I'm
Yeah.
saying.
I
But
won't
sir,
penalize
what you
that.
would recommend then is just to put everything in the calculator and just get that final answer and
Absolutely.
round it up.
Absolutely.
Okay.
Absolutely. So I
All
won't
right,
penalize
sir.
it better.
Just
Yes,
just to
please.
go quickly. So we got that 1.1599, and they actually rounded up to 1.560.
No, sir, you can't.
And
You can't because the
so
other number after the 9 is less than 5. Me know the problem. All I want to have, the problem all I want to have when I don't like work with silvers in the pocket. You don't want cash. Paper money no want. You don't want a silver. So you don't want to have no coins. That's the problem.
We don't want to nice with me.
See me so. So that's the problem. 5385. And then that's going to be equals to what they're gonna I could do this. It's going to be equals to 3 times 0.5385 square minus 8 times 0.5385. So 0.5385 square times 3 gives me, yes please, 0.8699, and then I'm gonna have 8 times.
See, that is what I'm telling you. That's what I do. Where you are do this, so that's what I do. Well, not exactly, sir. But how comes
Mhm.
you don't round off the 9? There is a 5 behind that 9,
No,
and
my
that would
my
make
calculation never give me a 5.
Mine
oh,
give me
I
5.
forgot that because it's because of how me I do it. That's why.
Yeah.
So, good. But sir, yeah, it's still. You know what? I'm not gonna make this mad me. I'm gonna just do it the
I
way
bet you, I
sir
bet, I
said
bet, I
to
bet,
do
I
it.
bet you get, I bet
Just
you get this answer that I
continue
have.
on.
Four
That
three
me
eight
get,
one.
but me just talk about the 8 or you know round off it to 8.7.
You got 3481. Three. You got this.
I got 3.438 negative.
But me can't tell me 8 alone in the comedy detail. So 4 decimal places, so me expect one next number after the 8.
So remember, because of what I use, that when I round it off, it will become a 0. So
8
that's
0.
why
No,
I'm
well,
getting.
so that's the point. That's the point I'm making. So
Oh, say
don't just
why
say 8.
0 too?
Absolutely, because it's 4 decimal places. Yeah, man.
God. All
Yeah,
right.
man. All right. So now for the third iteration, x3 is going to be equals to 0.5385 minus negative 0.0037 over negative 3.4381. So x3 is going to be equals to 0.5385 minus, and then no, that is going to, if I can put 1 over x equal that multiplied by 0.00370037. Boy, what the heck? 0.0011. All right, let me calculate this differently because 0.0037 divided by 3.4381
And that might get
0.011. Good. Yeah, I did it a second time and got the same answer. Good. 0.5385 is equals to
0.5396.
0.5374.
What is 5.3 get 7.4?
That's the answer I got, sir.
Sir, oh yes, get 7.4 now.
5385 minus all of that. Remember, who said I got that answer with me?
Oh, you get 7.4,
Nicole,
sir.
sir.
Oh, go drop Nikki W. This piece here is going to be a positive number, but this
Oh,
this
yeah,
piece
yeah,
this
yeah.
piece is still negative, so it's going to be a
Oh,
negative
yeah.
added there.
So,
Very good, Nikki. Daniel, you're quiet. 5385.
I didn't hear you, Mr. Shan.
oh,
Say it again.
no,
Yeah, I didn't
sir.
hear you. What you were
And
saying?
I'm saying you're quiet, and I don't know
Mm-hmm.
what is going through your head.
Right. So the latter part of the equation that you're doing there, that is what I'm currently doing.
Okay.
Mm-hmm.
Um, 53 5385 5.54. All right. So in the interest of time, I'm just going to show you something so that um Daniel can see where I am going in the interest of time. But I did say 3 decimal places, and I would want us to go one more with it, but I won't keep you any longer. But I'm just going to show you something. So I want you to do X4 for me on for your homework. So Daniel, not Daniel, Nigel, I will send some questions. I'll send some questions, but I want you to work on this for me. I want you to work on this for me, but I just want to bring across this point. What if the question had asked me to evaluate one of the roots of the equation to 2 decimal places? Would I need to do to find an X4? Would I need to find an X4?
No.
All right, tell me why.
Because up to even the second iteration, you would have gotten a similar
No, don't tell me
answer.
similar. Give me the answer. Don't tell me similar. Give me what the answer is.
0.5, you would have get 0.53.
No, ma'am. To
Um,
2 decimal places that I've gotten?
oh, sir, correction. You would have gone up to the third iteration, and then you would have get 0.539. And
No, hold on. Hear my question again. I'm asking, what if I'd asked you to give me the question up to the second 2 decimal places? Would I need to do a fourth
oh, it
iteration?
would be 0.54, sir. Yeah, that
Okay, good. So I'd have
0.54.
0.54 for the second iteration. What will I have for the third iteration?
Same
0.54 as well. So
0.54,
that
sir.
would
Very
be the
good. All right. Okay, great. Daniel, you see where I can tell you my endpoint now, Daniel?
Well, repeat the last part of what you
All right,
said.
because you're not paying me no man, Daniel. You're getting distracted.
Well, I was completing the equation, so
All right.
I was getting excited about that.
All right. So I want you to do
Mm-hmm.
I want you to do the iteration one more time because I want my answer to be 3 decimal places. But in the interest of time, I just wanted to highlight something for you and the other students in the class. And
Right.
highlighting this to say, what if I wanted my answer to be to 2 decimal places? When I look at my first iteration, I got 0.50. But when I look at my second iteration to 2 decimal places, I'd have gotten 0.54. And when I look at my iteration for the third one, I'd have gotten 0.54. Now, the mere fact that I got the same answer for 2 of them in succession, it means that I
Right.
don't need to do anything more. I'm ending right there. You follow me?
Yeah, definitely.
Because if I did a 4th iteration, I can almost predict what the fourth value is going to be. The fourth one is going to be 0.53 something. 0.53 something, and the third value is going to be greater than 5. And therefore, I'm going to be able to, if I were to use 2 decimal places, my answer would still be 0.54. So it don't matter how many iterations I would have completed thereafter, I'm still going to get 0.54 for 2 decimal places. But in the interest of time, what I want you to do, I will just set it out and then I ask you to do it for me. Nigel, you need to go work on your rounding off business here, Papa.
And this is to
Yes, sir.
accomplish what exactly? To see if it is equal, comparing all the answers for each iteration.
No, you calculate the root. That's the way you do. You have to calculate the root, and the root you calculate.
Okay, so it doesn't end at the iteration. You would have to discover the root at the end of it.
The end of the iteration is the root.
Okay.
So now you're going to find for me f of 0.53. I won't keep you for that. You are going to work out that for me, f of 0.53. You're going to tell me what that answer is. Then we have f dash of 0.5374. You tell me what that is, and then you're going to say your x4 is going to be equal to your x3, 0.5374.
I'm gonna get the same answer as x3 for that.
So when you work out x4, you got
Right, the 0.5374.
0.5374. So therefore, to 3 decimal places, that means your answer x is going to be equal to 0.537. And that will be the solution, if that's what it is that you're saying. Everybody
Okay, so it
go
is
ahead.
projected then to have the iteration to have the f of x equation calculated and then the f and then the x of n, right? After that, you would have the root calculated at the end of the iteration, which is based on the answer, how many times you iterate. That's the case?
All right. So the first part of what you say, me not go respond to that one day, because I think that is going to be something that you ask me up top. But I'm going to respond to the last part of the question. The last part of the question is the final answer that you get is going to be the root of all of this. And I would say yes. You're saying that the root is going to be 0.537. 0.537. Let us check to see if we can get 0.537 very quickly right here. 0.537. So I'm going to check it up here so too. 0.537 cube minus 4 times 0.537 square plus 1. Evaluate that for me, please. Zero point five three seven 0.537 cube is what? Zero point five three seven cube.
0.552.
0.552.
Sorry, 0.1552.
Hold on. 0.1552. I'm going to do the second piece where you get.
No, sir. Hold on there, sir. You say if my you do 537 cube.
Yeah.
When I do that calculation, I'm gonna get 0.155. I need more than that. Can I treat this in my case here, you, sir?
It's 3 decimal places at once. I'm going to work in 4. So it's going to be 0.1549.
Then
And then now 0.5. Oh, no, don't not use the calculator now. That's the problem, you know. 53 squares times 4 is equals to 1.153 plus 1. I'm going to add up all of that. Tell me what you get. 0.1549 plus minus 1.1535 plus 1 equal 0.0014, and to 3 decimal places is 0.001, which works out to be approximately equals to 0. You follow what I'm saying, guys?
Yes, sir.
When something equals 0, that means they found what? On the root. When you substitute, when you find the root of an equation, and you substitute that value into the equation, you get 0, don't?
Sir, repeat that.
All right, hold on. Y is equals to
because everything times 0, I got a 0. That's true, sir?
2x. No, not that one there. Let me give you this. Hey, it's the one no, on a played me, you know. Say x. Say
Sir, it's not that but I believe it, sir, but it's like when you say you plug, are we plugging in the 0 into the expression here? We say like, you know, to the third power and to the second power. But if you do that, you get 1.
Work with me right here, so look at what I have in pink right here, so 2x plus 1 equals 3. I'm trying to find the value of x. Work with me. I'm going to say 2x is equals to 3 minus 1. Talk truth.
Sir,
Yes, sir.
sorry, sir. What?
Yes, sir.
What a side work? What a side?
Yeah, that's what I'm trying to. That's what I'm trying to explain. I soon answer you. I'm just trying to explain this here. So 2x plus 1 equals 3, and I'm going to transpose to get 2x is equals to 3 minus 1. Do you agree?
Yes, sir.
Yes,
And then
sir.
I'm going to have 2x equals 2, don't?
Yes,
Yes,
sir.
sir.
So to find the value of x, I'm going to divide both sides by 2. So x equals 1, don't?
Yes,
Yes,
sir.
sir.
All right, good. So what happens now is that when I substitute the value here, 2 times 1 is?
2,
2.
And 2 plus 1 equals?
3.
3. So if I am trying to find the root, if I'm trying to find the root of an equation, as I showed you the other day, and I said to you, and let me show you this thing wrong. And I said to you,
Wrong, sir.
I said to you that it cut it down here, so don't.
Yeah, same way, so, sir.
Good. What's the value of y right here, so?
0.
Very good. See it right here, so 0. So what I did, because I'm trying to find the exact root, the answer that I get, I substituted into the original function, and I'm going to get 0. So anywhere it cuts along the x-axis, y is equals to 0. Put it this way.
Sir,
Go ahead, please.
All right, and that's the aim of the iterations.
Full stop.
To have okay.
Full stop.
All right.
What I'm going to do, guys, I'm going to work this question. I'm going to type out this question. But I have already done that. But anyhow, I'm going to see if I can. I'm going to send something off to, for you, and I want you to look at it. I know we were off for quite a number of weeks, and you don't really get into the groove of, getting back to school yet. So, a little rusty, need to brush off a little cobweb, kind of take up the brain cells. So I am going to ask you to look back at this. It's really not difficult. It may take us a while to go through the question because I was trying to explain. Trust me, after this, you can do one of the iterations in 5 minutes, 10 minutes at most. All right?
Guys, I'm going to share a video in the group that helped me today because I did not understand anything because I missed out most of the class, and that's what helped me today.
Please and
Along with
thanks.
sir's explanation.
And then
It's the same question as well, same exact question that sir.
Great. And then no Moya, and then no, based on what I just did a while ago, Moya, it kind of concretized everything, right?
Yes, sir.
Good
Yes.
job. All right. Thanks for bearing on with me for 17 minutes over. But we will have more of these Friday nights. We will have these sessions. Big up on yourself. We'll talk next week. I'll send off something for you over the weekend. To Moya, and she will share in the group for you. Yes, please.
Sir, one more question, actually.
No. Before you go, before the question.
Oh,
Before
the weekend.
Your weekend is a birthday weekend?
I said by the weekend.
Oh, by the weekend, yeah. But guess what happened now? It's all right. Well, whatever it is, try hunt me down and find me. What do you think you're here for? Pretty looks alone? All right, guess what happened now? For those of you who are not, who are joining for this Calculus 2, please to drop your information in the chat so that you can, or Moya, do me a favor, just drop the link in the chat so they can join via the,
certainly.
Right,
The WhatsApp group.
The WhatsApp group. Right. Because I will communicate with Moya, and then Moya will disseminate the information for me. But
sir, I had a question.
Go ahead.
All right, so since you arrive at the point of zero at the iteration, would that mean simply that you then would move on to no other iteration because you arrive at zero, you have no...
We say done. You done. You done. You suck out the juice out of the chicken foot bone already. Done. Nowhere else for go. Done.
I hear you.
Done. Axial done. Curry goat done. Yeah, man.
All right.
Anyhow, incidentally, this is big school mathematics here. Big school mathematics. So students at the university are learning this stuff here. You will see a little later on, all of what I am doing now is really to culminate into a topic that is called optimization. And I will give you functions that you will have to now go and predict your maximum profits and your minimum profits and, well, let me not say maximum and minimum profits. That is calculus 1. I will give you questions where it is that you can minimize your profit, right? Because what it is that you want to do is to say, you know what would be the minimum profit that I can make or can earn from doing this. And then again, I'll give you something that is going to talk about Lagrange multipliers, where it is know that you have to go on and do some other stuff. So it is to culminate. So try and make sure that you understand this little piece here, because it's going to come back again to catch up on you for some other area. But anyhow, thank you very much. All right, guys, have a good weekend. I will cool off a little bit, and Maya and I can have a little conversation, and then she'll send up the information to you. All right, guys?
So,
you go. Yeah, man, take care.
Sir.
Cool.
Sir,
man, please.
Question.
Go ahead.
You have Canvas up in relation to the course outline and all.
I am going to send that. I'm going to send that off to Mario today, so you can get it in your WhatsApp as well.
Wonderful. All right. Thank you.
Blessings.